And here is the Chapter 3 review, solving systems of equations. This first technique is solving by graphing. Pretty straightforward in that you're going to graph both lines. Remember that these are the y-intercepts. So this first equation, we highlight it in red, it would be starting at 3, and it's going to have a -2 slope. Negative slope means down 2, 1, 2, to the right 1, and down 2, to the right 1. Or you can go up 2 to the left 1, up 2 to the left 1, so forth. Once you have enough points, you just connect the line, and then you repeat the process with the other graph, and that is going to be down 7 is where we start. Sorry about that. Let's rearrange here. Down 7 and up 1 over 2. Up 1 over 2. They should connect at a nice point, at least for our examples. That's not always the case. And remember that that solution does have a proper way to be written, and that's going to be 4, -5. Please remember that it's x, y. And there's your solution. Okay, some of the other graphs you might see, okay, this is just another exercise of practice with negative slopes. We would start at -9 for the first equation, go down 2. Well, we can't, so instead we're going to go up 2 to left 7. 1, 2, 3, 4, 5, 6, 7. Okay, and then that's going to be connected almost like this. And our other graph starts at -3, and it has a positive slope up 4 over 7. You could also, again, go down 1, 2, 3, 4, and to the left 7, and then you'll see that they cross at that point, and connecting those together, lining them back up here, we have our corner point. Please do try and be rather precise when you are graphing. I know I'm kind of going quickly here, but just because they should connect at a nice point, and sometimes students don't quite get that point because they're going too quickly, sorry. -7, -7 is that intersection. Some other types to be aware of are, of course, if you have to solve for y first, make sure that you do that. So y is going to be -3x, negative y that is, -8, dividing everything by -1. Just means that first equation is y equals 3x -8, or +8, sorry. So graph that one, up 3, 1, 2, 3, or down to the left. So don't be afraid if you run out of space. Connect those together, bada bing, bada boom. Line it up here. And there's the first one. When you graph the second one, again, practice solving for y. -5y is equal to -x plus 30. And oftentimes, here's an example. When we divide by -5, remember that it's going to be y equals x over 5. Okay, or really 1x over 5. -6. I know it's a little sloppy, but a lot of times students forget that there's a 1/5 in front there, and that helps you find the slope. So starting at -6, we go up 1 to the right 5, or down 1 to the left 5, and where we'll see that these intersect is going to be about at this line here. So mine's not perfect. I'm going to check to see that I graphed everything right. Down 3, 1, 2, 3, and 1, 1, 2, 3, and 1. Yeah, and this first line's just off by a little bit. Okay, so the intersection point is at, remember, coordinate points, -5 and -7. Cool beans. Let's check out this next one. I think something special happened with it. Again, practice solving for y for both equations. I'll do that quickly here. Negative 3y equals negative 2x minus 24. Whenever we divide by negative 3, we're going to have y is equal to positive 2/3 x plus 8. When we solve the second one, the slope is going to be the same. And if you go through the whole process, you're going to find it's going to be y equals 2/3 x. And in this case, it's going to be minus 3. Okay, so you can double check that if you go through and take the steps. But notice that the slopes are the same. You should remember from Unit 2 that same slopes mean parallel lines. So let's see what happens here. When we graph the first one at 8 and down to the right 3, we are going to get this line roughly. And when we graph the other one, we're going to notice it's going to be parallel. Sorry, those points are off a little bit. And with parallel lines, the thing is, they never are going to touch one another. Therefore, there are no solutions to this particular system. And again, this point is off. Apologize about that. If they do not intersect, then there are no solutions. So be aware of fancy cases like that. Moving on, solving by substitution method. Remember that basically you're just plugging this, so y is equal to x minus 1, into y above. So you're going to have 4x minus 5, quantity x minus 1. Don't forget the quantity bit, which is going to be 4x minus 5 plus plus 5 equals 5. And if we then solve for x, so we're going to combine our like terms, subtract 5 is 0, and we get x is actually equal to 0. 0 divided by negative 1 does work out, it's just 0. Make sure then that you plug back in to find the other variable. So y is equal to 0 minus 1, so we're plugging in for x, which means y is equal to negative 1, and we have the coordinate point 0, negative 1. If both of them are solved for y, it's pretty simple. We just set them equal to one another. X minus 2 is equal to 2x minus 5. Solving for x, so we can move x to one side. Negative 2 is going to be equal to x minus 5. And then add 5 to the other side. We would have 3 is equal to x. And don't forget, plug it back into either of the originals to solve for y. Y is equal to 2 times 3 minus 5, which is 6 minus 5. So y is equal to 1. Properly written, 3, 1. That is our winning combination. Elimination methods, just a little different. The goal, again, match up the x's so that they are opposites, or the y's. But if I wanted to make, say, 8 the opposite of negative 16, I want this to become negative 16 somehow. Well, I do that by multiplying the whole top equation by negative 2. So doing that, you just need to remember that you need to distribute that to all 3 things. I'll rewrite that equation below it, so that's going to be 16x. Negative 2 times negative 8 is going to be another positive 16x, or y. And negative 2 times negative 24 is going to be negative 48. Now, the 2 equations we haven't touched yet, we are going to then just add them right together. You'll notice the x's cancel. 16 and negative 9 is going to be 7. And we're going to see that's equal to negative 56 when we add all these together. So then y is going to be 56 divided by 7, negative 8. With negative 8 in store, you can plug into any of the original equations. Remember though, we are solving for x, so we just found y, so we want to make sure we plug it back in for y in this particular case. So equal to 24 makes it 64, negative 8x, and subtract 64, leave negative 40 is equal to negative 8x, and divide by negative 8. X equals 5. 5, comma, negative 8. Elimination method. Sometimes you can cancel out the y's. So notice in the bottom equation here, if I just multiply this one by 3, it's then going to become 3x, negative 3x, sorry, plus 3y, plus 9y, my bad again, and negative 28 times 3 is negative 84. So now, when I add together the first equation and the second equation, the y's will cancel. I would have negative 14x, y's are gone. And remember to add together the negative 14 and negative 84. Sometimes students forget to do that. And it's going to be negative 98. 98 divided by 14 is going to be positive 7. So be careful with positives and negatives. Negative by a negative is positive. And then again, plugging it back into any of the originals, I'll use the first equation. So opposite of negative 7, or opposite of 7 is going to be negative 7. 3 times y equals negative 28. Negative 7 plus 3y, negative 28. Add the 7 over, negative 21, 3y, and y then equals negative 7. 7, negative 7 is the combo. All right. Sometimes you have your choice, whichever method you want to choose, substitution or elimination. In this case, if we multiply, say, the top by 5 and the bottom by 3, we're going to see what happens, and the x's will cancel. So top by 5 would be negative 15x minus 10y equals negative 10. Bottom by 3 would be 15x minus 27y equals negative 27. And then adding together, the x's will cancel. We'd have negative 37y is equal to negative 37. So y is going to be equal to 1 when we divide by negative 37 each side. Once 1 is found, plug it in, find the other. Negative 3x minus 2 times 1 equals negative 2. So negative 3x minus 2 equals negative 2. Add the 2 over. Don't be afraid if you get 0 on the right-hand side. It most likely, it can either be a special case, but 0 you can divide by any number except for 0, and we just get 0. So 0, 1 is that solution. Try any method you'd like. Come back, see if you get it correct. I'm going to use elimination. I'm going to do the top by 4 and the bottom by 9. So the top by 4 would be 36x. Bottom by 9. X's are canceled. 89 equals 89. Y comes out to be 1 again. And solve for x. and we get the same old solution, 0, 1. Cool beans. Moving right along, again, more substitution, elimination. You have your choice. I'll multiply the bottom by -2. I'm an elimination type of guy. And then focusing on these two equations, I actually just needed a +2. So I'm just going to change these signs up. That way the x's cancel. +2, -2. 16 is going to be equal to -16. X, that is. And x then will be -1. If I substitute -1 into the second equation, and I add 1 then, y equals 0. So -1 is 0. 12, multiply the top by -3. And again, there are different ways you could do this. These are just the methods I'm choosing. You should get the same answer regardless in the end. Y is going to be 3, and x minus 2 times 3, -10. X is going to be -4. I know the crash course pretty quickly through those. But again, try a method you like, go back and check them out. Alrighty. Some concepts just to understand. Two equations with parallel slopes and different y-intercepts would have no solutions. That's true. Okay, so they're parallel, kind of like our one graphing, and they have different y-intercepts. So that would just be representative of this here. Different y-intercepts, parallel slopes, are not going to have any solution. Different slopes would have no solutions. That is not the case. That's going to be false. If they have different slopes, they are going to intersect at one point. Okay, so maybe this one has a slope of -1/2. Maybe this one has a slope of 3/4. If they're different, they are going to intersect. If they line up exactly on the same spot, then they are infinite solutions. So that's true. So maybe if you graph one line, and then you graph another line, and you find out they're the same line, well, then they're infinite solutions. Some word problems. Basically, I'll help you set these up. Afterwards, it's all just the same old stuff. Doug's Donuts sells dozen donuts for $7 a box, and mini donut holes for 8. So, two equations, typically letting each of your variables, so dozens, I'll let be D, and M, I'll let be mini donuts. So let's think here. Dozen donuts for 7, box of mini donuts for 6. They made 52 sales. The first equation is typically going to have all your money in this case. So $7 per dozen plus $8 per mini, and that's going to equal $3.96. The second equation is just the number of things. So we sold so many donut holes plus so many minis, and in total that's going to be 52. So those two equations are all you need to set up and solve. The answer should be online if you check the answer key, but that's the general setup. Another example, so this time it's just looking a little different. Saturday sold 30 adult tickets, so 30 adult plus 60 child equals 510, and that's on Saturday. And on Sunday, it's just going to be 20 adult plus 55 children equals 400. Elimination or substitution would be the way to go from there then, setting those up. Inequalities, we actually do that in another chapter, so you can actually skip over those and really just focus on the first problems up to 17, and you should be all right. Good stuff, guys.